Hello and welcome back to the Farmyard Academy. This is the final video in the series, so if you've not checked out video 1 and 2 for mole calculations, I definitely suggest having a look at those because that sets the scene. But here we go, we're just going to use our three-stage method to calculate this exam question. So we go to the exam question, and the first stage is to write a question of what the question wants us to work out. So if we go through it, we can see here it says calculate the total volume in centimetres cubed of gas. So because it says gas, we need to be using the ideal gas equation, which is PV equals nRT. We need to rearrange that to make V the subject, so we need to get volume and leave volume on the one side. Now these terms are being multiplied, so all we need to do is remember our opposites. Anything on one side of the equation has to do the opposite on the other side, so it's V equals nRT, and to get the pressure over to the other side we do the opposite of multiply, it's divide. Okay, then we plug in what we can, and we're trying to work out the volume of gas. We go, have we been given the number of moles of gas? We haven't, so we put a question mark. Have we been given the molar gas constant? Well, we've not actually been given this in the question, but normally we do. We should know it anyway. It's a nice easy constant to remember. It's 8.31. Have we been given the temperature? And the temperature is 90 degrees Celsius, so it's 90 plus 273 because we've got to get it into Kelvin in the ideal gas, and we also then have to divide all that through by the total pressure, which in this instance is 300, and it's kilopascals, and we need it in pascals, so we have to multiply by 1000. And if you work out those brackets, you might get some marks for doing that as well. So that's a good start. Again, if we highlight though, all these questions very, very similar. Once you've broken it down, we've always got to work out, at some point, work out the moles. So that's why stage 2 is to work out the moles of something that's given in the question. If we go back to the question, we can highlight that they've given us information about the mass of calcium nitrate. So, and because they've done that, we can therefore use our mass, our mole formula for a solid, which is N equals mass divided by mR. Okay, I'm going to write calcium nitrate here so that we know we're working out the moles of the calcium nitrate, like so. So the mass that they've given us is 5 times 10 to the minus 2 grams. It's nice that it's in grams, always keep it in grams. And then we've just got to work out our MR. Now MR stands for molar mass, but really from GCSE what we say is it's just the big numbers. So you find the big numbers of these species in the periodic table and add them together. Calcium is usually 40.1, nitrogen is 14, oxygen is 16. We've got 3 here, so we're going to do 16 times 3, which is 48, so plus 48. And then we also have to multiply everything inside the brackets by 2 because there's a 2 here. So just again, it's 40.1 for the calcium, it's 14 for the nitrogen, it's 16 for the oxygen, but because there's 3 of them, 16 times 3 is 48. And then we just multiply that by 2 because there's 2 of those NO3s. If you work out that will give you the moles, and I'll just put that as an X, so I'll let you have a look at doing that. And then the final stage is to use a mole ratio in order to work out the moles that you actually want. So this is where you've got to be a bit clever. You've got to go through and you've got to look at, well, I've worked out the moles of, and I'll highlight it up here for you, I've worked out the moles of the calcium nitrate. But I don't want the moles of the calcium nitrate, I want the moles of the gas. Now here you can see in the products, calcium oxide is a solid, so I don't want that. So I'm going to cross that off, so we're not interested in that. But if we look, nitrogen dioxide is a gas and oxygen is a gas. So they've been a bit tricky here in the sense that you've got 5 moles of gas because 4 plus 1 mole of oxygen makes 5 moles. And then where you've got the calcium nitrate, you've got a 2 in front of it. So the actual mole ratio is a 2 to 5. Okay. So if you know the number of moles of the calcium nitrate, in order to work out the total moles of gas produced, you've got a 2 to 5 ratio. And how you convert 2 into 5 is by multiplying by 2.5. So in order for us to take our mole answer and to put it into our ideal gas equation, whatever we get here, we have to multiply it by 2.5. And if we then work out our formula here, we'll get our overall answer down here. Now, if we look at the question, there's still some marks available, because in the ideal gas equation, that answer will come out to be meters cubed. And the question doesn't want it in meters cubed, it wants it in centimeters cubed. So we need to remember that to get from meters cubed to decimeters cubed, we multiply by 1,000. And then to go from decimeters cubed again to centimeters cubed, we also multiply by 1,000, like so. And then if you do that, you get the final answer, and make sure it's in 3 significant figures. Okay, so that's it. Hopefully that's helped you. And like I say, I think if you keep it to those 3 strategies, stage 1, write the question. Stage 2, work out the moles of something. Stage 3, do your mole ratio. You won't have any problems. So hope that's helped. Like and subscribe, and we'll see you on the next one. Okay, bye bye.